Welcome everyone to today's CSIA webinar series. My name is Colin Hammond and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global nonprofit professional association with over 500 member companies in 40 countries. Our mission is to advance the practice of control system integration to benefit our members and their clients. Our vision is to ensure that manufacturing and process industries everywhere have access to low risk, safe, and successful application of automation technology. CSIA membership offers members access to resources needed to attain and exceed business goals. To highlight just a few of our many member benefits, the CSIA Best Practices Manual guides control system integration companies in the setup and running of a solid company. CSIA's Business Insurance Program offers members an excellent insurance program for business owners, subcontractors, and more. The program includes members from all over the world enjoying the peace of mind that comes with CSIA insurance. Clients in all industries are now seeking integrators with a CSIA certification alongside ISO. They recognize CSIA's certified integrators' commitment to industry standards and business acumen. As a result, being certified can shorten the sales cycle. CSIA Industrial Automation Exchange is the premier automation guide featuring system integrators and suppliers who provide industrial, manufacturing, and process automation solutions. For integrators and suppliers, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. And be sure to follow CSIA's online events calendar for all upcoming webinars, including partner webinars, business webinars, and our Wednesday webinar series. CSIA's business webinars features topics handpicked by CSIA leadership to help you run your business. CSIA partner webinars are opportunities given to CSIA's industry partners to address hot topics and demonstrate their expertise. You won't want to miss these opportunities to learn from the comfort of your own office or home. And for more information about CSIA, please visit our website or contact us at info@staff.controlsys.org or 847-686-2245. And at this time, I'd like to introduce our presenter. Scott Marsic has over 2 decades experience successfully transforming diagnostic, technical, and business intelligence project into innovative, market-leading goods and services. As Senior Product Manager at Epson America, Scott is responsible for developing strategic initiatives to help drive channel growth and end-user demand across the industrial robotics product category. Scott holds a BS from the University of California, Santa Cruz, an MS from the University of Southern California, and an MBA from San Francisco State University. And with that, I would now like to turn it over to Scott. Welcome, Scott.
Great, thanks a lot, Colin. Appreciate the introduction and really appreciate everything that CSIA has done for us, and working with you and Lisa has been fantastic. So thank you. Colin, just shared my screen. Is that coming through there?
Yeah, you're looking just fine.
All right, cool. Well, great. Thanks a lot, everyone, for joining today. We know these are crazy times, but we know your time is valuable. So thank you for spending a few minutes with us to discuss this important topic on parts feeding, kind of a topic that I think for myself, it's something you just always take for granted. You know, you're doing automation and it's going to be there, right? But it's an interesting space and something that particularly for new folks to this area, there's a lot to learn. And so we really want to broadcast information out that we've acquired over the past several decades. For folks that don't know, we've actually done a similar webinar called Automation 101. And that was designed for folks that were new to automation, and it had a fantastic reception to it. And from that, we received all these questions. People were asking, how do I do that? I don't understand this. Tell me more about that topic. And really, that's how this particular webinar came about. So without further ado, let's jump into Introduction to Parts Feeding. So to kick this off and to take a step back, as many folks on this call know, many folks, particularly in the CSIA organization, have been involved with robotics and automation for some time, and it's been around for a long time. I mean, since the mid 20th century. And early applications were focused on heavy industry, automotive, etc. But since then, automation's changed a lot. It's become more affordable, more accessible, more precise. And so it's branched out into a lot of different product applications. So things like your sunglasses, pacemakers, hearing aids, cell phones, all kinds of consumer electronics and consumer products are made by robots. And more are being made every single day. And so at Epson, we actually got started in automation about 4 decades ago. And the genesis was that we were building our own products, like say our Seiko watches, very precise products by hand. And we began looking at that and, well, how do we scale it up? How do we manufacture it quicker, lower cost, more effective, more precise? And so in the late 70s, we began developing our own robots. And so that was how we got started in this space. And if we take a look at where our core focus is here at Epson, it's generally around the manipulation of parts that are small and can easily fit into the palm of your hand. So we are all about high speed, high precision. And so things like assembly or pick and place or palletizing or packaging, these are things that we work on quite a bit. But the most common application to Epson robots is assembly. And if you're going to assemble something, you have to have parts, right? You can't assemble something without the parts. And so that gets us into this question of, well, gee, Scott, why are you talking about parts feeding? Well, in a nutshell, all different parts or products that are manufactured are made up of different smaller components or parts. And in order to make these products, you will need to pull in the individual parts and then assemble them in some way. So if you want your automation process to be successful and efficient, you will need these components available for quick access, number one, and two, they've got to be available in an organized fashion. So if we use, say, an example cell phone, there's literally hundreds and hundreds of parts that are required to build that cell phone. Same thing goes for pacemakers or hearing aids or even hard drives. In all cases, there's typically a lot of different parts required. And the parts need to be presented to your robot in an organized and consistent position so that the robot can go in, pick up the part, and do something with it. So this process of making parts available is called parts feeding. And as I mentioned when I started this presentation, parts feeding is kind of one of those things you just take for granted, right? But it's a vital topic to automation. And so this is what we're going to be covering today. So before we dive in deeper, important to talk about one aspect of parts feeding, and that's a term known as singulation. So during a manufacturing process, often you'll receive something like what you see in this bag here, a big bag of parts. And this bag of parts might be useful to a human. So you receive this and you use your eyes to open the bag. And then you use your eyes and fingers to find a part, pull it out one at a time. And then you use your fingers to orient that part and do something with it. And then you go off and continue your assembly process. At a high level, applying robotics to this process is really no different. Yet to start, typically what is required is that the singulation or the separation of all those parts from the bag. So you've got to make sure that they're separated. And once they're separated out, they can be individually found with a vision system, machine vision, or they can be singulated using bowl feeders so that the robot can go in and pick up the parts one at a time. So when we discuss parts feeding within the context of automation, spreading out the parts so you can access them one at a time is an important concept. And this is known as singulation. So here's where we're going to go in this presentation today. We're going to start off by going through some of the key things that you should consider when selecting the right feeder for your application. Next, we'll talk about the different kinds of feeders. We're not going to cover all of them. There's a plethora of options that are out there. We're just going to cover some of the more common feeders used today. Third, we will cover some of the trends that are driving parts feeding today and what we've been seeing at Epson. And then finally, we'll provide you with some guidance as how to get started. So first topic, selecting the right parts feeder. So for this topic, we're going to take a look at and give you 5 key areas that you need to consider as you begin to think about which feeder you want to use. These are important considerations because there are definitely a lot of choices that are out there. So it's important to do your due diligence up front. And in no particular order, you want to be thinking about what's your part type? What's that part type's complexity? What are the future needs for your parts? Don't just think about now, but be thinking about 3 years out, 5 years out, 10 years out. What's your part mix? A big part of what we will address is volume versus variety or changeover. And that brings us to throughput. How many parts do you need in an hour? And of course, last but not least, there's always cost. So you're always thinking about the cost of the system and your ROI. All right, so part type and complexity. So some of the things that we want to think about, of course, when considering part type and complexity is, what is the part? You know, is it a simple part with, say, 6 sides like a block? Does it have multiple sides that the part can fall on when fed? What's the part length? What's the part width? What's the thickness? How about the material? Metal parts are, of course, a lot heavier than plastic parts. So moving them around in whatever feeder you have takes more effort. Rubber parts, as another example, they can tend to stick together and can present movement problems on a vibration tray. The slide here lists out just a few examples of parts. And as you all know, there's a gazillion parts that are out there, all sorts of different types, fasteners, clips, and connectors. But here's the thing you really want to watch out for. Things like clips or parts that have different kinds of grooves or protrusions can potentially get stuck or bind together. And remember the topic we started off with, singulation. It's really key. You want to be looking at your parts through the lens of singulation. Can you separate the parts out? Simple parts, so take, for example, that block, have typically very fast throughput. More complex parts can be a little slower and sometimes require special tooling or take some special setup. When we start to look at part complexity, such as a part with protrusions, this can cause the part to have multiple possible orientations. That can impact singulation. You also want to consider whether the part is wet, whether the part's oily. Sometimes the feeder will require a special feeder lining or a special powder to get those parts not to stick together. Sometimes a special feeder coating might be required, such as polyurethane or nylon or even brushlon, to help singulate the parts and help them not stick together. At Epson, we have a team of application engineers that work daily with customers on application studies, a lot of time on these singulation studies. These engineers will take in customer parts, place them on our feeders, and make sure that they will singulate well so that they function both properly and meet customer objectives. So an important takeaway here is make sure when you're looking at all this and you're considering part type and complexity that whoever you work with, whatever robot vendor or parts feeder supplier you have, will go ahead and take the time to give you that confidence that you will be able to singulate those parts. It's an important topic I'll come back to later, but make sure that you do the testing and make sure whoever you work with helps you with that. Next, you want to consider both your current and your future part needs. This is really something that you want to think about when you're considering your feeder type mechanism, because you're going to spend some money on this. You're going to have some investment in time as well. So what's important here is not just to think about what you may need for the next, say, 3 months for a given project. Think about what you might need down the road several months later. So let's bring back the cell phone example. As you all know, probably all too well, cell phones transition quite a bit, right? It seems like every 6 to 12 months, you got a new cell phone coming out, new version. So after a period as short as 6 months, you will likely need a different set of parts for that cell phone. You don't want to get a feeder that you end up having to throw away or not be able to use a year later. Ideally, you want to get the maximum use out of your feeder investment. So make sure you think about your current and your future part needs. You also need to consider high product mix that requires high changeovers versus having parts that you will just keep making over and over the next 5 to 10 years. If you're in the automotive market, for example, the typical trend is that they will make the same part for 3, 5, even 7 years. But again, in the electronic space, there's a much quicker turnover or changeover in the products, where every new product is introduced with new parts. And those new parts need a feeder. And that feeder either needs to be new or needs to be adaptable so that you can adjust to the changing trends in your parts. So this brings us to another consideration, volume versus variety. So here we show 2 common types of feeders, a bowl feeder on the left and a flexible feeder on the right. We'll spend more time about these different types of feeders later in the presentation, but a lot of times, just thinking about volume and variety, a lot of times the part volume or the parts needed per hour or per day will determine the feeder type that you need. If you have a high part volume and a low part mix, then very commonly a bowl feeder will be used. They're very quick. On the other side of the spectrum, if you plan to change parts every 3 to 6 months, like that cell phone example, we even have customers changing weekly, things we see with our applications department here at Epson. Then a flexible feeder might be the better option. So as I mentioned, we'll get more into depth into each one, but just think about what your volume and your variety mix needs are when you're considering your feeder. Now let's talk about throughput. So here are some of the trade-offs to consider. And we talked a lot about this in our Automation 101 presentation. Cycle time or speed, precision, and flexibility. So on the bottom left, we show an equilateral triangle labeled perfect world. So in a perfect world, we would have the best of flexibility, the best precision, and the fastest speed. But as we all know, we don't always live in the perfect world. And so a lot of times we have to make trade-offs. So in making those trade-offs, you want to make sure you think about what is your highest priority. And that might vary application to application. So let's say, for example, that your highest priority is the creation of 1 million parts per week. You therefore require that throughput be very fast. Additionally, in this process, the precision for the product relative to some other applications you might be working on is not as critical. So you, as a builder or as a customer, are able to reduce precision for the benefit of increased speed. Finally, you need to think about how often you will be doing changeovers. Different parts may require different throughput and precision levels. That is the flexibility part of the equation. So be thinking about these 3 elements and what your needs are. Last consideration in this section that you want to think about, and as I mentioned, last but not least, is cost or total cost of ownership. So let's say, for example, we're building a generator. The generator's got 9 different parts that are required to build this generator. And so we have 9 different parts and we need to feed those. So if we're using bull feeders, for example, bull feeders can range, $20,000 to $40,000 a piece. So if we use the low end cost there, we might be spending upwards of $180,000 for all those bull feeders. If we're required to build the same product with the same parts for the next 5 years, and during that time we have to build out the millions and millions of the same generator, the bull feeder is definitely the way to go here. However, what if we need to change these parts every year or every 6 months? And when things change, maybe the screw type is going to change. Maybe a gasket will change. Maybe some other piece will change at some point. And so when this happens, we will very likely need to take the bull feeder out and bring in a new bull feeder, and that will cost us even more money. An alternative option is to use a flexible feeder. In using flexible feeders, we can make a little programming change for the vision system to find the new part, and now the robot will be able to pick up the new part. This presents a flexible solution without the big cost of purchasing a new bull feeder each time you have a new part. So when calculating your total cost of ownership for your given application, make sure you include all these different factors. Make sure to include not just the purchase price, but factor in how long you intend to use the feeder, how often you will change parts over, or how often you'll have some sort of changeover occurring. Some feeders take more setup, some take more maintenance than others, so don't forget about those costs as well. All right, so those are things to think about as you look at feeders. So in the second section, we're going to take a look at some of the different feeder types that are out there. And as I mentioned, there's a lot, right? So this is just some of the more common ones that we see. Bull feeders, of course, on the left there, but also gravity feeders, step feeders, and conveyors will be considered because they all feed parts within a given work cell environment. And of course, we'll cover flexible feeders, which have been around for a while now and are becoming more and more popular because of the need for flexibility. All right, so first off, bull feeders. Bull feeders are definitely the champion when it comes to making sure you have a part available so that the robot can continuously assemble or continuously do something with that part without any lag in time. Bull feeders typically work through vibration. So parts are dropped into the center of the bowl and they vibrate around the outside along a track. Bull feeders are custom made by literally gurus. Folks have been doing this a long time that really understand how to make the parts fall back into the bowl so that they were properly oriented when they are fed and presented. The beautiful thing about a bull feeder is that there is always a part waiting for you. As such, the robot can have very quick cycle times. However, in terms of cost, bull feeders are more on the expensive side. They have to be made custom. The changeover is okay, but you do have to move from one bull feeder to another as each feeder is made for a specific part. So this brings us to part mix. Again, a bull feeder typically works with one part. And here's where the problem comes in. If you have to change that part just a little bit, oftentimes you have to change the bull feeder. So if you need super high throughput, bull feeders are the best option. Next, we have gravity feeders. So these were common years ago, still see them a bit today. In the example that we're shown in this image, we're packaging chips. So as part of this process, you'll get a tube of chips for assembly, line them up, place them on the gravity feeder, and they'll fall. This is pretty useful application, but can also be very expensive and doesn't necessarily have that high precision. Parts get dropped down and then they sit where they lie. But if you're doing a food application where changeover, precision, and part mix are not a super high criteria for you, a gravity feeder might be something to consider. So third, let's shift to step feeders. These are typically used for bringing up bulk parts. So you're not typically singulating down to one particular part. You are more using, or rather you are more pulling out a bunch of parts at one time. Step feeders are used to pull parts up to a vibration feeder or possibly a conveyor. There is no real precision in this feeder option. Step feeders are typically used for one type of part or one kind of part, like lots of different kinds of screws, as shown in this example. Then we get to conveyors and conveyor tracking, which is another kind of feeder or mechanism that could be used. So imagine that there are a ton of different types of parts that we can potentially pick up, similar to what is shown in this image on this conveyor. A lot of robot vendors have today conveyor tracking options available, so their customers can apply this to their automation work cell. Epson also has an integrated conveyor tracking solution where we can pick up moving parts off a conveyor. Changeover is an area that conveyors really excel at because you can change parts from part A to part B very easily as long as you have the software already in place for the vision system to identify and pick up the new parts and the required grippers. So on the changeover and part mix side, big thumbs up for conveyor tracking. Excellent solution. In terms of part volume, you will need to go a little bit slower versus a bull feeder because you are picking up parts off a moving conveyor belt. And one of the things you give up as well is precision. You can fix that precision by adding an upward camera. You can pick up the part and move it over the top of the upward camera to see where it is held by the gripper and then go and place it. And that would certainly help with your precision. And now we come to flexible feeders. So flexible feeders are very strong in the changeover and part mix area. Typically, we can place one part and change to a new part very easily. The way flexible feeders typically work is that you have some type of vibrating tray that shifts the parts around. And then you will have a vision system, which takes pictures of the components to help see whether the parts have been singulated. The robot then comes over and picks up the part, just as you see in the example here. And if designed properly, the whole system is able to do all of this fairly quickly. However, one of the things you have to think about every so often is that you do have to vibrate the feeder to get the parts separated and singulated out. So I will tell you that one of the advantages of the Epson IntelliFlex feeding system, which is what you see in that image there, is that it does not have to spend as much time vibrating. The system uses artificial intelligence, which is able to figure out where the parts are and where they need to be moved, and then how to move them. So for example, if the parts are bunched up in the corner, the feeder automatically spreads the parts out for you. So it allows you to have a little faster throughput. However, even with that, one of the disadvantages is that the part volume does not compete with the bull feeders. Bull feeders are usually the speed champions, while flexible feeders are better at handling changeover. Cost is also an advantage, as you can use the same robot, the same vision system, and the same flexible feeder for multiple projects. So in summary, here's a high-level comparison of the different types of feeders. As you look at your projects, things to think about as you evaluate what you need. So bull feeders, as I mentioned, do very well with throughput and precision, but have some disadvantages in terms of cost and with part mix, as it can only work with one part. Gravity feeders are average with throughput and cost, but are still very specialized types of feeders. Step feeders are more for moving parts a lot of parts at the same time. Conveyors are used in a lot of applications. Changeover and part mix are excellent. Throughput is good, but not necessarily as good as a bull feeder. And finally, flexible feeders excel when you have high part mix and low part volumes. You will give up a little on throughput versus the bull feeder, but where it gains is in the changeover and the part mix department. All right, trends driving flexible feeding. So want to cover some of the things that we've seen, some of the things that probably you have seen as well. and considerations as you move into the space and look at your different options. So flexible feeding is becoming much more common today versus say 10 years ago. One of the factors that's driving this is mass customization. And so we're seeing much shorter product life cycles than we did 10 years ago. Products, if we're looking at that cell phone example, might be 6 to 12-month runs, and then the product changes. So maybe it has a different color, or maybe a different configuration, maybe a different size. Cell phones are a really good example of mass customization, changing with high frequency. Unique products like this with shorter cycles are what's really driving that need for flexibility in your automation. Another trend is miniaturization. So we are continually making things smaller and smaller. Think about a car cell phone from 25 years ago versus what we have today. I have visions in my head of Gordon Gekko, and Wall Street walking along the beach in the 80s with that gigantic cell phone, right? And think about what you have today with your Bluetooth headsets and all that. Dramatically smaller parts, smaller overall product. And with those smaller parts, it's becoming increasingly difficult to handle the parts by hand. And so you need automation for that type of part assembly. And the assembly, this is where flexible feeding is really helping out in that miniaturization space. Another area is part complexity. So this area is also a key factor that's driving change in this area. Complex parts are difficult to move through bowl feeders. In many of these cases, the flexible feeders are able to singulate and separate out the complex parts, find them with a vision system, and pick them up for assembly with a robot. And so people are moving towards the flexible feeders in that area. All right, so let's talk about getting started. So far in this presentation, we've laid out considerations, things to think about with your parts. We've laid out the different types of options that are available to you, and some of the trends that are happening in this area. So as you begin to put together what you need for your particular application, start thinking about the essential components that you will need. Will you need machine vision or not? How do you optimize your parts for feeding? What are some of the landmines or problem areas that need to be on the lookout for? And then finally, how do you put everything together? How do you integrate all this stuff? All right, so essential components. So first off, in most cases, you're going to need some kind of feeder and some kind of hopper. What you will see here is an Epson IntelliFlex feeding system with a hopper attached that will serve up parts. The parts will drop into the feeder where the feeder will vibrate and singulate the parts out for the robot to pick in place. The same general setup is true if you're using a bowl feeder. With a bowl feeder, you'll drop all your parts into the center of the bowl, and then they'll vibrate around the edges all the way around to the outer edges along a ridge until they're all the way out at the top. In both cases, you will have a hopper and a feeder. In the case of the bowl feeder, the hopper is built into the bowl feeder. Then you will need a motion device, something to pick up and manipulate the part. You can use a robot, such as a Scera or a 6-axis or Delta robots. There are many options to pick up the parts and place it for assembly. Scera robots are best for fast cycle time or super high precision. This is an area where Epson really excels at, and we can definitely help you with that. And do think about payload requirements. Payload is not just the weight of the part, but also the end of arm tooling. So don't forget to evaluate both when considering your payload requirements. Real important piece of information there. And finally, you'll need a robot controller. The robot controller can control all components, or you might want to drive this through a PLC or some other mechanism. So essential components: feeder, hopper, motion device, and controls. So when do you need machine vision? So typically, flexible feeding and conveyor tracking requires some sort of machine vision. There are exceptions, as sometimes conveyor tracking can be done with other sensors, but usually you've got some sort of vision system in there. Machine vision is used to find the parts. Think of this as the eyes of the system. And as such, it's critical to be able to find different parts. It's also critical to make sure you singulate the parts. That's where vision comes in. If you have a high mix of parts, the vision system can definitely be programmed to detect part 1, part 2, part N fairly easily. So let's talk about feeding optimization. And there's definitely a couple key areas to consider. The first area is what we'll call staging, or a staging area or preloading area. And so this is done in cases where you need to make a continuous cycle. You need to hit a certain time every time. So let's say you need to place a part every 2 seconds. If your application is, for example, running an average cycle time of 1.5 seconds, as an example, then most of the time you're not having any issues. But what about during the time the hopper is putting more parts into the feeder? During this time, you have to wait for new parts to be loaded and time for the parts to be singulated before you can pick them out. Maybe this takes a few seconds to do. Since you can't miss placing a part, because remember, you've got a cycle time expectation of 2 seconds, this is where staging comes into play. So one way to leverage this idea is to build a staging area in your system with 5 to 10 part nests close to the feeder. Before you start your complete system, let the robot and feeding system preload the nest positions. Now that you have, say, 10 parts in the nesting positions, each time your hopper needs to load more parts, you can have the system pull parts from the nesting positions to make sure you hit your 2-second cycle time. Then during the regular cycles, when you have extra time, you can reload the nesting positions in between placements. So that's staging. Second is end-of-arm tooling. So another method to make pick-and-place applications more efficient is to use what's called multi-headed tooling. And what this means is building tooling at the end of the arm that instead of having one gripper, it has 2. Each will require a plunging mechanism to move the tool up and down to pick up the parts. Then when you locate the parts in the feeder, you can pick up a part with tool 1, then rotate and pick up a second part with tool 2. Next, move the whole arm to the placement position and place the part from tool 1, then rotate and place the part from tool 2. Overall, this helps save cycle time since you place 2 parts with each overall motion cycle. So there's other areas to think about with optimization, but this gives you 2 ideas to think about with respect to parts feeding and how you can optimize your given application that you're working on. All right, pitfalls to avoid. So things to avoid or at least be cognizant of. So as we discussed up front in this presentation, you always want to consider your part features like shape, length, width, and look at them through the lens of singulation. Will those parts I have easily separate out? Do they have the potential to bind together? Here we've listed in the box some very common example parts. Springs in general, which are listed here, can be very difficult to separate out. Extremely thin parts can be difficult to singulate. Soft and flexible parts that can change form can sometimes present challenges. And round parts that roll around can be difficult to stop. So there are multiple solutions to all of these, and there are options. And Epson, as I mentioned with our application engineering team, can certainly help you with that and give you some guidance. Part complexity is also another area to consider when you're looking at pitfalls to be cognizant of. The more complex the part, the more difficult to singulate and feed the parts. But the most important thing, the most important takeaway that I want to make sure people take away from this particular slide is to test your parts. Before you buy the components, before you buy the feeder, test your parts. You definitely want to work with a company like Epson or Feeder Expert to guide you through to the right solution. Another pitfall is not knowing your priorities. You need to determine upfront whether cycle time's needed or flexibility. Understand the trade-offs. That perfect world doesn't always exist, and that you might need to give up something in order to have another aspect of your application be optimized. So, as I show in this example, sometimes cycle time is more important. Sometimes flexibility is more important. If cycle time is a top priority and not parts changeover, then a bowl feeder might be the best option. But if flexibility is key and you have a high mix but low volume part need, a flexible feeder can be the way to go. Sometimes it's not straightforward, so I recommend you talk with your robot or your feeder vendor for the best option. And always, always test the parts before you purchase the components. Another pitfall to avoid is fixed cycle time versus average cycle time. So fixed cycle time is common with rotary indexers or with 5 or 6 stations. Each station has to do something. Imagine a part that has to be assembled every 1 second. You need a part every 1 second, not an average of every 1 second. Then there is average cycle time, which is the average over a large volume of parts. Let's say you need to hit an average of 1 second, for example. The two applications are very different. The benefit of flexible feeding in this particular example here is that flexible feeders can accommodate both scenarios. And as I mentioned earlier with optimization, things you can look at, staging or end of arm tooling can also be implemented to help hit your required fixed cycle times when you've got those continuous parts feeding requirements. So then finally, who will build this? Great thing is we're on a call with a lot of great builders here at CSIA, people that really understand automation, are wizards at putting things together. And so for the end users out there, for the people that haven't been in automation before, you know, this is something new you haven't worked with before, think about who will do this work, right? Do you have the resources in-house or a robot expert? You know, who's going to be the person that's going to kind of like lead the charge on assembling all this? Bowl feeder integration is fairly easy. So connections just an I/O, input/output. There is more work required for flexible feeders. And that can range from difficult to easy because it involves multiple components, a robot, a feeder, and vision. The integration level, therefore, depends on which type of feeder you use. Epson introduced the IntelliFlex feeding system, which has an intelligent feeder and can move parts in an intelligent way, not just shake and pray. And because IntelliFlex is built with Epson Robots, feeder, and vision, all integrated together, parts feeding has now become much easier with much less development time than putting all those separate components together on your own. So be thinking about all this in the context of who's going to put this together and what resources do you have. So I appreciate everyone's time. We covered a lot of ground here. We went through a bunch of good topics that, as I mentioned, I think it's something that sometimes we take for granted. But parts feeding is vital to any automation environment that you're in. And so hopefully this gave you some good nuggets of information to be thinking about as you move forward into your projects. So what we covered, parts feeding is required for most assembly applications, right? It's out there. Make sure you think about your current and your future needs and what parts you have. Consider all those aspects. There are many different feeding solutions available depending upon your part needs and requirements. And so we went through 5 different options, but there's others that are out there. So be thinking about what your needs are and which one matches up the best. We talked about the trends that are happening in parts feeding, mass customization, miniaturization, and parts complexity. They're all driving that trend, and we're seeing the uptick in flexible feeding as a result. Be cognizant of the pitfalls out there and how to avoid them. I mentioned a few, there's others. Work with somebody who's an expert in this space, and they can really guide you through other considerations to think about for your application. And then finally, most importantly, test your parts. Don't just take folks' word for it that this is going to work or that's going to work. Test the parts. Epson Robots is more than happy to help you in this area as your needs come about. So with that, want to thank you for your time, and I'll take your questions at this time.
All right, Scott. So I'm happy to report we have some questions. So let's begin with, which feeder type is the best for parts assembly that involve a high mix of different components?
Yeah, we talked a little bit about this. So this is really where flexible feeders come in. So flexible feeders, as I mentioned, they use vision to differentiate or singulate out parts. And having parts separated or singulated is kind of the name of the game with this, right? You need to be able to identify those parts and move them apart, right? Whether it's a spring, a nut, a screw, whatever. And so the vision system is really what helps to differentiate what you have. It helps to identify the part that the robot goes in and gets. So it's a combination of those different parts, and flexible feeding really is the way to go in that particular environment where you have a mix of things.
Okay, thank you, Scott. How do I know whether the feeder can accommodate my part?
I mentioned a few times throughout, and I think it's just important to reiterate that, whether, you're looking at a gravity feeder or a bowl feeder or a flexible feeder, you have to test it. You have to make sure you put it through its paces, because you're going to spend some money on this. You're going to spend time and resources bringing it in and implementing the solution. So you want to test it. You want to make sure that it works. Bowl feeding experts, for example, are just super knowledgeable about how to design feeders to work with a certain part. I mean, they've got years of expertise, but even as they go through their process, they're testing things. They're testing to make sure that it works. Flexible feeders have to be tested as well to make sure that the vision system can find the part, or that the part can be singulated. I mentioned some examples, just with oily parts or complex surfaces. Until you test, you just never totally know. And if you need to get a part into a certain orientation and it just won't go there, sometimes you just can't force it. You just can't make something happen. So test the part. That's really the big takeaway with that.
We have a question on machine vision. Is machine vision required to get started with parts feeding?
Machine vision, yeah. So to get started with feeding, no, there's all sorts of feeders that don't require vision. We talked about bowl feeding, as an example. But that's working with one part. As you get into more complex feeding options that have flexibility, vision does become much more important. Becomes your eyes to be able to see what's happening, and so flexible feeding solutions do require some sort of vision, but not completely true. You need vision for every feeding example, but it is often required.
You talked about parts feeding with springs. How well do parts feeders accommodate them?
Springs. Yeah, springs are a challenge. Springs or clips can be a challenge because the parts will interlock, and springs can be challenging based upon the how tightly they're wound. Right? If the spring wind is very spread out, interlocking of the parts can become a big issue. When you're going in to reach the part, you don't want to go in and reach a part of, or reach 3 springs at one time. You want to singulate out the individual springs, and if they're interlocked, you can't do that. And no amount of shaking is going to bind some of these parts. But springs, for example, you can have tighter coils. You can have something that's more like a cylinder, and it being a cylinder, interlocking is less of a possibility. But springs can be a challenge. It's back to testing. Make sure that you test the parts. Make sure that you go through its paces and see if it is possible with what you have.
All right, thanks, Scott. We have one on the Epson system looks similar to other flexible feeders in the market. How does yours differentiate?
Yeah. So it's a good question, and an important question as it gets down to integration and ease of use and just overall implementation. So we use an Azrael feeder, but we don't just take an Azrael feeder and sell it into the marketplace with a low-level connection. We really at Epson spent time integrating the feeder in with our RC Plus environment. So that's our programming environment for robots. And we integrated not just the feeder, but we integrated in the vision system. And so by doing that, we've dramatically reduced the time for our customers, the time required to build out a flexible feeding system, because it is a system, right? It's a system of a robot, of a feeder, and a vision system. And so because we've spent that time putting all this together, there's no need to build communication between vision and the feeder. And the vision system has full integration with the robot, so you can singulate very quickly. You can teach defined parts very easily. The parts can be tuned with the system. So as I mentioned, it uses artificial intelligence to identify where the parts are. That's done with the vision system, and then the feeder will vibrate to move the parts. But it's not just random vibrations. It's tuned to move the parts to where they need to go based upon where they are, and the vision system does that. And the fact that it's all integrated just makes it more or less seamless. It's just much easier. We didn't write 100% of the code for you, maybe 90%. So you still have to write a little bit of code, maybe a little pick and place routine in order to get things where you want it to go. But it's pretty straightforward in RC Plus. It's a very easy environment to use. And by doing all of that, really our goal was to help customers in this parts feeding environment where flexible feeding is much more valued and needed based on market trends, but also save you, whether it's the builder or the customer, time. So save you weeks, if not, more in development time, so you can get up and running and do what you do best.
Thanks, Scott. So we have a few more. I'm just gonna pick a couple here. At what PPM do you no longer suggest flexible feeders?
Parts per minute. That's a challenging question to answer. I mean, it does come back to I don't want to rely just totally on the testing part. You do need to test. We routinely do parts feeding in the 3 to 8 second cycle time range all the time. We can do less, but we really need to look at the parts and look at your process and figure out with you how we can optimize it and things that we can implement to try and optimize it. So, it depends if you're looking for average time or you're looking for continuous time. You need to look at the parts reloading, the singulation time, etc. How complex the part is. As I mentioned earlier, simple parts have faster throughput and complex parts slow down and sometimes require more fine tuning or special of the system. So there isn't a hard and fast number, I guess, calling to that question, but important to test and important to ask all those upfront questions and get help from your resources and evaluate your options.
All right, and then we have, where should parts be sent for evaluation?
So I can speak for Epson, right? I can't speak for other manufacturers or other folks in the space. Again, I guess to conclude on this, test, right? Testing's really key. And so at least at Epson, we have customers that work with their distributors or their Epson account manager, and they will typically queue up the process. And sometimes, when our apps engineers are looking at this stuff, they've just got, decades of experience doing this, and they can look at a part and say, no, that won't work, out of the gate, or no, that'll work. Let's take a closer look. So they can save some time up front there. But then once that feasibility study happens, then parts are sent in to our applications team here in California, and things are tested out. But whether it's Epson or whether it's another manufacturer or somebody else, make sure you go through those paces. Make sure that you do test and have the confidence up front to make sure things work for your given application.
Thank you, Scott. So on behalf of CSIA, I would like to thank Scott for this informative discussion. I'd also like to thank all of those attending. We hope you found the webinar informational. We'd also like to remind you that a recording of this webinar will be available for viewing. You will get a link that will send to your email address probably an hour after this, and I will have the video sent to the webinar archives not too long after that. And be sure to see the CSIA website to view this recording or a past webinar you may have missed. And please be sure to check the events calendar for future webinars. We'll be hosting a digital transformation task force tomorrow, and we have a lot more coming up. So that concludes our program for today. Once again, thank you for joining us. Thank you, Scott, and thanks all the attending. Have a good day, everybody.
Thanks a lot.